Hey all, this is Alan with Bothell STEM Coach, and today we are continuing on with AP Physics free response questions. And so let's take a look at this is waves and sounds. I always suggest you pause the video, attempt to do the problem, and then come back after you've attempted the problem. So I have a hollow tube of length L, is open at both ends as shown and held in midair. A tuning fork with frequency F0 vibrates at one end of the tube and causes the air in the tube to vibrate at its fundamental frequency. Express your answer in terms of L and F0. Determine the wavelength of the sound. So this is open. Let me see. Open at both. So the fundamental frequency wave looks like this. It's got to be an antinode at the open ends. Okay. So that means L here. Oh no, it's actually capital L. At least in the word problem, it's capital L. So L is half a wavelength. Half a wavelength. So that means the wavelength is equal to 2L. Okay. Speed of the sound inside the tube. Well, it's F0, so the velocity is always lambda times frequency. Lambda is 2L, and the frequency is F0. So that's that one. C, determine the next higher frequency at which the air column would resonate. Okay, so here you want to draw a picture of what the next shape of the form is. It's got to be open, so it's open. Ooh, that wasn't good. It's probably open, closed, and then it opens again like this. Yeah, so that's the next smallest wave I can fit in. That's an antinode, or it's open at both ends like that. Okay, so that was terrible. Okay, just imagine I'm like way better at drawing than I am. I know it's a big stretch of the imagination. So let's see. This is open to here. Let's see. That is. Oh, how many wavelengths is that? That's one whole wavelength. So L is equal to lambda. So our wavelength is L in that case. Oh no, that's not what they asked. They asked for the frequency. Okay, so the wavelength here is L. And to find the frequency, again, this equation, F is equal to V over lambda. V is constant, 2L F0, because it has to be constant, because the speed of anything in the same medium is constant, and the wavelength is now L, so that's 2F0. I guess that was pretty obvious. Double. This is why we call it the second harmonic. Like if this is the fundamental frequency, 2F0 is the next highest one. So, okay, the tube is submerged in a large graduated cylinder filled with water. The tube is slowly raised out of the water, and the same tuning fork vibrating with frequency F0 is held a fixed distance from the top of the tube. Determine the height h above the tube when the air column resonates for the first time. Okay, so this time what's happening is because we have a water, it's actually closed at this both end. So like if this is the water level in the tube, this is the smallest wave that can fit in. And the smallest wave that can fit in is 1/4 of a wavelength. Like this is 1/4 of a wavelength. If I were to extend this wave out, like this is 1/4 of the entire period. And the smallest wavelength, well, so the let's see, expression in terms of L. Yeah, so for this wavelength, this is 2L, right? So 2L times 1/4. At the fundamental frequency, it was wavelength 2L. 2L times 1/4 is L over 2. 1/4 times 2L. Yeah, 1/4 times 2L is equal to L over 2, or 1/2 L. Okay. Okay, hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.